Okay, so welcome to this bite-sized video on working with grouped data, and let's dive straight in. We've got an example here. There are 80 students and their exam results expressed as percentages are given in data groups, right? So one of the things that we need to be able to do is find an estimate of the mean. Now, it's not possible to get the mean exactly because we don't have access to the raw data. Although Simi says he actually saw the original ungrouped data and he calculated the mean to be 55,8. Let's take a look at how we're going to tackle this. We're going to use this formula here, which says that the mean of a set of data is the sum, remember sigma notation, of the products of the frequencies times each x value divided by the total number of data items. Right, so our challenge now is that we don't know, for example, that one person who got a mark between 10 and 20, we don't know whether they got 11 or 19. The safest thing to do is to give them the midpoint of that interval. So what we're going to do now is we're going to put in the midpoints. So for example, that one person, we would assume that they got a mark of 15. This is an assumption, which is why it's an estimation, but on the balance of things, it should kind of work out okay. So we're saying that those three people basically got marks of 25, that they averaged out to 25. Right, so we fill in all those midpoints. The next thing we're going to do is we're going to calculate that product of the frequency times the midpoint. Okay, so we do all of those, 1 times 15, 3 times 25. Right, remember sigma notation means add all those things up. When we add them all up, we get that. And now we divide by the total number of students, which we said was 80, right, and we get our final answer. Right, just before we calculate actually how close that is, because it is pretty close, 56,4 as opposed to 55,8. Just want to quickly show you how we use our calculator in this context. The first thing really important is to make sure that our calculator has the frequency mode displayed, and I'll just show you how we do that. If we go shift mode, that's the same on both calculators, then the down arrow, and then choose stat. On the newer or the fancier calculator, it's option 4. Here it's option 3, and we can turn frequency on or off. We definitely want frequency on. Now we go normal mode into stat mode. All right, one variable, and we put in the numbers. When we press enter, so we're going to put in our midpoints as our x values, so 5, 15, etc. All right, and as we press enter, it goes down. So it's actually easier to do all the midpoints first, and then to go back up and put in the actual data values of 0, 1, 3, etc. Okay, and then once all our data is in, we press all clear, we go shift stat. If we want to get back to our data, we can press 2, but if we want the variables about our data, we press 4, and we would choose option 2 for mean, and you can test this yourself if you like, but you'll see that we get 56,375 actually. In terms of a calculation of the accuracy, well, here's the percentage error. It's actually just over 1%, which is remarkably accurate actually as an estimate. The next thing we are often called on to do is to plot what is called a cumulative frequency curve or an ogive curve. Okay, so we've got the same data as previously. We now created what's called a cumulative frequency. Cumulate means to kind of add up, right? So what this 4 tells us is it tells us that so far we've had a total of 4. To get the next entry in the cumulative frequency, we take the previous cumulative frequency and we add 12. So it's just accumulating, right? And what that 16 is actually telling us is that 16 people scored 40 or less. Right, so we complete the table. The number at the bottom of the cumulative frequency column is our total number of data points. Now we're going to look at what points we need to plot. First thing we're going to do is we're going to label the axes. On the horizontal axis, we've got the mark, and on the vertical axis, the cumulative frequency. Cumulative frequency always on the vertical axis. The very first point we plot, right, is slightly different from the others in the sense that we plot the lower value of the lower boundary value as our x value against our cumulative frequency. Right, the next point and all the points from then on, we plot the end point of the interval against the cumulative frequency. Right, so the end point of the interval against the cumulative frequency, it's only when I say the end point, the upper boundary, the right hand end, all right, it's only the first point where we in fact use the left hand end. Right, so the next one would be 30 and 4. The next one would be 40 and 16, and so on. Now we plot those segments of lines. Right, there they go. And this is a fairly typical cumulative frequency curve shape, right? It's almost like a sort of stretched out S. The really important thing is that it maxes out on the y-axis at the total number of students, obviously. Okay, so there's our cumulative frequency curve. Now, very often we are asked to take some readings off our curve. So the first one, estimate the interquartile range. Remember, the interquartile range divides the data up into quarters. So we're going to go a quarter of the way up the y-axis to the cumulative frequency, and we're going to read off Q1 there. Then we're going to go 3/4. Now 3/4 of 80 is 60, and we're going to go there. If we wanted a median, we would obviously go halfway up at 40 in this case. We read off those data items, and remember, interquartile range is just the difference between our third quartile and our first quartile, and we get approximately 22. When we mark this stuff, we are lenient with sort of give or take a couple of marks or units either way, all right, but try and work as accurately as possible. The next thing that we get asked is, suppose the top 10% of the students are awarded a certificate. Use your graph to estimate the mark required to get a certificate. Right, well, the top 10% of 80 students will basically mean that you've got to finish in the top 8. So we're going to read off at 72 to see what mark that gives us. All right, it looks to be about 77%. Finally, just a little observation here. We could get asked to find the modal class. Now, that's the class that's the most common. Obviously, if we've got in other words, the one with the highest frequency, if we've got the data, then it's obviously easy. We just look for the biggest number. But in fact here, because all the widths are the same, we're going to look, if we weren't given the data, if we were just given the graph and we asked for the modal class, we're going to look for the piece of curve that's got, or piece of line that's got the biggest gradient, and it's actually over there. Right, so the modal class is actually 50 to 60. Hope you found this useful, and hope you have a great day. Bye now.